first kind of equation we're going to look at is the easiest. We're going to give you equations that are going to be so easy to solve. But stay with us, practice with us. They're going to get harder before the end of the chapter. We're going to look at equations where we solve them by what you add to one side, you add to the other. Please do it our way. We have a plan. Thanks. I'm counting on you. Well, here I am with my favorite balance. Now, I want to make another point. Some of you kids are too smart. When we start equations, and we teachers are crazy to teach you what you do to one side, you have to do to the other side. And some of you look at our equations and you say, "Are you crazy, lady? I know the answer. I don't have to do all of that." Well, I have something I want to say before we start. If I say to you 2 times some number is equal to 4, some of you say, "The heck with that balance stuff. Why should I have to think about balances and doing equations? 2 times some number is 4. I know what the answer is. It's 2." And you get the answer right. And sometimes parents call me and say, "You took off because my son didn't do the problems your way. He got the right answer. Isn't that the important thing?" Well, no, it isn't the important thing. The important thing is getting the idea of this balance in your head so that you don't do anything illegal when you're building a bridge or you're solving a real world problem. The original equations that we give you when you're young and don't know very much can be solved by what we call inspection. But when things get complicated and really useful, you can't solve them by inspection. So you have to learn the rules of an equation, which are what you do to one side, you have to do to the other. And we teachers want to teach that to you. In fact, we're sort of neurotic about that. And we don't want you to do it your way because you're too smart. We want to say, yes, you're smart. You can solve stuff by inspection. But we are going further than that. If all we wanted was the answers to those equations, we could Xerox the back of the book. Don't you think we already know the answers to those equations? We give you simple equations because we are moving on to harder equations. So obey us. Thanks. Bye. Okay, today we're going to look at equations where you add or subtract from one side and the other side to keep your equations balanced. So I'm looking here at the main menu of How-To software. We're going to Algebra 1 Unknown. Now, I didn't do a tutorial on this so much. I just did this easy math. So here we're going to look at problem type, and we can look at the pattern. This is where we have a number added to the x equals another number. A lot of times students like to do these problems by inspection. What number plus 2 is 3? And a lot of times they'll say, well, the answer is 1, Miss Howe. And it is the answer, and I get a smiley face if that's the case. But I want you to think in terms of subtracting 2 from this side to leave x alone, and subtract 2 from that side and get the 1. So here's another problem. X plus 4 equals 9. The way I want you to think about doing this, not by inspection, not by guessing, not using your wonderful brain, but trying to get the rules established in your brain. That the way you solve for this x is do the opposite operation that we have here. The opposite of adding is subtracting, so we'll subtract 4 and we will get 5, and we look to see if there's a 5, and there is, and so I get that one right. Now here we're going to the opposite of subtracting 3, so we'll add 3, so we get x. Minus 3 plus 3 cancels each other out. 6 plus 3 is 9. I don't see a 9, so I'm going to have to work another problem. Now I'm going to add 9, so this looks like this would be -1. Look, I've tricked you into doing another problem. Subtract 7, this is going to be 9 again, and it's not there. So this time we're going to add 4 to both sides. We get -3. We get that. And we're going to add 5 to both sides. We get -4. And we're going to add 6 to both sides, we get negative 10. We're going to add 10 to both sides, we get negative 5. We're going to subtract 2 from both sides, we get negative 12. I don't know which ones of these 12. I can only have one. I guess I don't know which one would be best. Doesn't really matter. Subtract 6 from both sides, that negative 10. We already used negative. Oh, and there's another negative 10. Add 5 to both sides, we get negative 1. There is no negative 1. I get to do another problem. Add 5 to both sides, that's 8. We get that one. Congratulations. You might want to use this program to practice simple equations where you add and subtract. I don't think it'll take too many games before you get good at it. After you get good at that, then you might want to change to another type, and that is the problem type where you have something multiplied by the unknown. And let's look at this. Well, we did adding, and we snuck in subtracting from both sides, because subtracting is just adding the opposite. Next, we're going to move on to multiplying or dividing, because those two things are opposite of each other. When you divide, you're really multiplying by the reciprocal. So we're going to do one-step equations where you either multiply or divide both sides by the same thing. It's not much harder than adding or subtracting, but you must keep it straight. Don't mix the adding and subtracting ones up with the multiplying and dividing ones. There's more to come. Stay with us. Algebra 1 is easy. Bye. Those problems. Negative 3x is equal to 33. This time, the negative 3 is not attached to the x by a plus. It's sitting right beside the x, so it means times. What is the opposite operation of times? It's division. So this side we divide by negative 3. We have to divide this side by negative 3. 33 divided by 3 is 11, but a positive divided by a negative is a negative. We get negative 11. This time we're going to have to divide by negative 2. So 18 divided by negative 2 is negative 9. Notice I haven't used my calculator. For simple problems like this, a calculator just slows you down, and you will not get a good ACT or SAT score unless you learn your times tables and your addition facts. Just work on them. Go back to foundational topics if you're weak at these until you get good. And it'll take you about a week to repair the damage. We're going to divide by negative 4. We get negative 5. Here we're going to divide by negative 5. We could get negative 10. Here we're going to divide by negative 11. We get negative 11. I don't have that. I get to do another problem. Divide by 4, I get negative 10, which has already been used. Divide by negative 9, I get 5. Negative divided by negative is positive. It's not there. Negative 96 divided by 12 is negative 8. Not there. Negative 48 divided by negative 12 is 4. I'm looking for 4. Oh, divide by 1. How hard is that? I've actually seen kids use a calculator to divide 11 by 1. There's something wrong with that. But we couldn't do it anyway on this one. This one is negative 3. There we go. Negative 1. Hopefully. This is negative 3, unfortunately. I was hoping it was a 3. This one is negative 2. This one is 10. Not there. Oh, yes, it is. 8. 5. Not there. 5. Again, not there. Negative 6. Not there, I don't think. Negative 6. Maybe I did that. Maybe it was there the last time. Negative 6. Negative 11. Negative 11. 4. No 4s. 8, not there. Negative 12, 1, negative 1, negative 1, negative 11, negative 12, negative 7, 0, negative 1, negative 9, 3, aha. Like I said, a couple of games and you will be home free on one-step equations. Just do the opposite of what you see. I don't think we can go, yes, I guess we could do something like this. This time the problem is 7x. X divided by 5 is negative 2. So in order, when x is divided by 5 is negative 2, what do we have to do to get rid of this 5? We would have to multiply both sides by 5. So this would be x. We multiply by 5 on this side, and multiply by 5 on this would be negative 10. You can have fun with this math though. Thanks. Bye.